This is my battery bank, a pair of 225 amp hour 6 volt golf cart batteries connected in series for 12 volts. Longtime subscribers have seen this bank before because it's the battery bank that I've used in the camper on road trips for, the past 4 years. And when not on road trips, I've used it for backup at home. And but that's been just kind of a turn it on when I need it kind of thing. And this is still working fine, but sorry about that. That is that's the inverter. This is my 12 volt 1500 watt Go Power pure sine wave inverter, and it draws too much current. And part of the reason it draws too much current is because of that fan. My big inverter doesn't even have a fan, and it draws a lot less current. We're talking idle current. But anyway, so that's the noise you hear, is that fan. But I will probably replace that inverter soon. And as you saw in another video very recently, I bought a 24 volt inverter intending to use it, and it turns out that it draws way more idle current than this one does. This one draws too much, but the one I ordered, according to the specs on it, not the published specs in the advertising, but the specs that are listed in the owner's manual that came with it, it draws about 4 times as much current as this one does. So, and that's at 24 volts versus 12 volts for this one, so that's, beyond unacceptable. So I sent it back, never even hooked it up. And so anyway, this is still working fine, but the problem is I'm getting ready to start using it full time to power some of the stuff in the house. And so this one is going to go back to being just a mobile setup, and I probably will buy another inverter, but I've decided to stick with 12 volts and not even bother with 24. But I have bought another battery bank, and I bought it I bought 4 of them, and intending to use it for 24 volts, and I've decided instead to connect it series parallel for 12 volts. And because everything I've got is 12 volts as far as inverters, and I've decided that 24 volts is really not, it doesn't offer enough advantages for me. 12 volts advantages in my system outweigh the benefits of 24 volts. But anyway, what I want to do is set it up so it's powered up 24 hours a day to run my network and my telephones, and also be available for short-term loads besides that. And so anyway, with that, let's get to work installing the new battery bank and see how it goes. Okay, now we've got it. So this is a series parallel, 12 volt series parallel set of L16s, and they're 370 amp hours, so each of them is 6 volts. So what we've got here is, right here you can see the little short jumper. So this is positive, negative. Right over here we've got the same thing, positive, negative. So since those are going to positive, negative, it means that this pair of of batteries adds up to 12 volts. It makes one 12 volt battery. 12 volt 370 amp hour battery. This one makes another 12 volt 370 amp hour battery, and the reason is because these are the only series connections. These are parallel. So here we've got positive to positive, negative to negative. So that means that this is a 12 volt connection, positive and negative, and this is a 12 volt connection, positive, negative. And by connecting the positive to positive and negative to negative of those two batteries, that the voltage stays the same and the capacity doubles. So that means that we've got 370 times 2, so we've got 740 amp hours at 12 volts.